Many times when we are outputting data, we want to put it in a specific form so it is easier for the user to read, or perhaps the output of our program will be used as the input to a different program that expects the input in a certain format. In some of our earlier programs, we output values with many digits after the decimal point, when it would have been nicer to round to a few decimal places. This video will show you how to nicely format numbers, or strings, or a mixture of numbers and strings. Python has added different ways of formatting strings as the language has evolved. I think the most recently added technique that was added in Python 3.6 is the simplest to use, but it was added after the third edition of the book was written, so it is obviously not covered in the third edition. This video will show this new way of formatting strings. Let's revisit the date convert example we looked at earlier. I've replaced the input statement with a hard-coded date so I don't have to enter a string each time I demo this example multiple times. The print statement to output the date works, but it uses a mixture of 4 expressions and string concatenation to get it formatted exactly the way we want. In this version, we're going to use what is known as a format string or template string to generate the string in the format we want. The way it works is you create a string but put the letter F for format before the quotes that begin the string. For text that you want to appear exactly as it is, you write the string as we have been. In locations where you want to place the value of a variable, you use curly braces and put the variable name inside the curly braces. Here I've placed a second print statement that outputs the exact same line as the original print statement. Note the F before the quotes and the curly braces surrounding each variable name. All the characters, including any spaces inside the quotes but outside the curly braces, are output exactly. Since we want one space between the month name and the day of the month, there is one space between those two sets of curly braces. Since the comma should be immediately after the day, there is no space after the curly brace for the day string. One other advantage of the second technique is we can create a string using the format syntax. We could then send the string S to a text object in a graphics window or print the string. With the first example that prints the results, we cannot get the exact string as each expression is output separately by the print function with a space between it. The only option is to print it out either to the console or to a file. If we write this, we are creating a tuple of 4 strings. It is the same as writing this, or with lists instead of tuples we would write it like this. The string formatting technique allows us to create the string and then choose whether to print it, use it in a text object, or use it as part of another expression. The other advantages of string formatting are we can indicate whether to left justify, center, or right justify the value of the expression in a certain number of spaces, and for floating point numbers we can control how many digits after the decimal point to display. This is an example program that doesn't do anything useful, but does demonstrate how string formatting works with strings and numbers. Let's debug it and step through it so we can see what each line does. First, I printed out numbers to make it easy to see and count the spaces in each example. I've created the string Hello World, which contains 11 characters. By default, strings are left justified. Inside the braces after the variable name, you put a colon, followed by the number of spaces to use for that variable in the string. We'll step over this print statement to see its output. I printed square brackets so we can see that the string includes extra spaces at the end in order to left justify it in 20 spaces. Since the left square bracket takes a space and the string is 11 character, the D ends at column 12, and since Hello World is 11 characters and we left justified it in 20 spaces, we have 9 more spaces as we can see. And then the right bracket is in column 22. This is because there are 20 spaces for Hello World and 2 characters for the square brackets. We'll step over the next example that shows you put a less than sign after the colon and before the number of spaces to indicate left justification. As you should expect, we see the exact same output since the default for strings is to left justify them in the specified number of spaces. The greater than sign is used for right justification. The way to remember which is used for left justification and which is used for right justification is to think of the sign as an arrow and it points in the direction in which you are justifying. The less than sign points left and the greater than sign points right. I've output this one without the brackets since we can tell there are spaces before the string. As you should expect, the D ends at column 20 since it is right justified in 20 spaces. The caret symbol is used to center a string. I've used the square brackets again so you can see that spaces are placed both before and after the string to center it. In this case, we can't center it equally, so there are 4 spaces before the string, then 11 characters for the string, followed by 5 spaces after the string. If we try to center the string in fewer characters than the length of the string, it outputs the entire string, so it's as if we had specified a center or left justify or right justify it in the exact length of the string. I printed the columns again so we can see how the numbers are formatted. By default, numbers are right justified. This is normally what you want so that the numbers line up in the corresponding columns. We will output x and y both right justified in 5 spaces so you can see the numbers line up. If we wanted to, we could use the less than sign to left justify number or the caret to center number just as we did with strings, but numbers are usually right justified. For floating point numbers, we can either specify the number of digits after the decimal or the number of significant digits to output it. It is much more common to specify the number of digits after the decimal so the numbers line up correctly. After the colon, you specify the total number of digits, then a period, then the number of digits after the decimal point to display. So in this example, we were outputting the value of pi right justified in 8 spaces with 2 digits after the decimal. Note the decimal point counts as one of the 8 spaces. So there are 4 spaces, the number 3, the decimal point, and then 2 more digits. You can also format a constant as this shows. Since we use the same formatting of 8 total digits with 2 digits after the decimal, the numbers will line up. When using string formatting with floating point numbers, it does round up the last digit if the next digit is 5 or larger. Since the first few digits of pi are 3.14159, the 9 causes the 5 to be rounded to 6 when we output it with 4 digits after the decimal. If you leave off the f, the first number after the colon is still the total number of spaces in which to right justify the value, and then the period, and then the number after the period indicates how many significant digits you want to use. In this case, the format string says to right justify in 9 spaces with 4 significant digits. That results in 3.142, which is 4 significant digits, and 5 total characters with a decimal point. So there are 4 leading spaces to total 9 columns. If the number cannot fit in the specified number of spaces, it still displays the entire number. You might be wondering what you do if you want a curly brace in your string, since the curly braces are used to indicate we are substituting the value of the variable inside the curly braces. You use 2 consecutive beginning curly braces to create 1 beginning curly brace, and 2 consecutive ending curly braces to create 1 ending curly brace. In the first example, there will be a space after the left curly brace and a space before the right curly brace. If we didn't want those spaces, we'd have 3 consecutive curly braces. The first 2 indicate 1 curly brace should be in the string, and then the third one is the one that indicates we are substituting the value of items bracket 0. This program shows one more option with string formatting. We'll start with what we've learned so far, and then show how this new option would be useful. We have a program for inputting the number of each coin denomination and outputting the dollar amount at totals. Since floating point numbers are not stored exactly, it is better to do the calculations with integers so we can get the exact amount. The total we calculate will be in cents, but we want to output the amount in dollars with 2 digits after the decimal. We can calculate the number of dollars using integer division and the number of remaining cents using the modulus operator. We use string formatting to output the dollar amount in exactly as many spaces as it needs, and then we want the number of cents right justified with 2 digits. Let's run it and enter 3 quarters, 2 dimes, 1 nickel, and 2 pennies. You can see the output doesn't look like we want it to, as it right justified the 2 cents in 2 spaces, but used a space when we want a 0 there. If we hadn't told it to right justify in 2 spaces, we would see 1.2, which would mean $1.20. Python string formatting allows you to specify the character to use to pad a string by placing it after the colon and just before the justification character. In this case, we will place a 0 before the greater than sign, since we want a 0 to be used if there's only 1 digit. Now when we run it with those same values, we get the output we want.